The main advantage of using the binary search is that it does not search for each and every element present in a list. This binary search algorithm applies only on a sorted array. The only limitation is that the elements must be sorted for the binary search algorithm to work on it. Hello everyone, it is Dr. Ravi Kumar YB. Let us learn about the machine architecture and assembler chapter. In this unit 1, you will come across the searching techniques. In my previous session, I discussed about the searching technique, which is linear search. That is, linear search is one of the basic searching technique which is used to search any item in a desired location of an array. Similarly, we have one more searching technique called binary search. We shall see as to how we can find out the element of an array so that the required element is present in the array or not is going to be obtained for successful search. If the element to be searched is not at all present in the list or an array, then we say that the search is unsuccessful. For all these possible cases, we shall see how the binary search works. Now, a binary search is a technique. The word binary means two. We will split the array of elements into two. That is, if I have an elements of this order, this is a single array. Let me call this array as this. Totally, we have 6 items in this list. Bi means 2. Nary, the binary means array. We will split the array into 2 parts. That is to this part. Now we have towards the left part, I have this element. Towards the right part, I have this array. This is the process of using the pointers or the variables which can keep track of either towards the left side of an array or towards the right of an array. Now, looking at this binary search, which is a searching technique which searches the middle element which is present in an array. The main advantage of using the binary search is that it does not search for each and every element present in a list. I am using the word each and every element present in a list. In the previous session, I discussed about the linear search, wherein you found that the elements present in a list are searched from one end of the list to the other end of the array. That means starting from the position 0 to the n-1th position, the elements are searched sequentially. The word sequentially was used when I was explaining about the linear search. But this is not the case with binary search. A binary search is a searching technique that helps you to identify the element which is present in an array by employing 3 important parameters. The first parameter is left. The second parameter is right. The third parameter is middle element. That means we have 3 parameters here. One of the parameter is left, and the other one is right, and the third one is mid. Now, instead of scanning each and every element present in a list, the searching operation divides the entire list into half of it based upon the comparison operation performed on the middle element. That means if I have an element to be searched in the list, and if the element to be searched is greater than the middle element, we will shift these parameters from left to the mid plus 1. Similarly, if the element to be searched is less than the middle element, then we shift the rightmost parameter from right side to the mid minus 1. So the same conditions are going to be applied in the next slide. See here, this algorithm uses the strategy of divide and conquer. First, it divides the array into two equal parts. Then it applies the conquer strategy. That is, whether the element required to be searched is present in the list or not is going to be achieved by employing the divide and conquer strategy. That means there are three possible cases in this binary search algorithm. The first case is, the possible case is, when the element to be searched, that is data, is less than the middle element. Please listen here carefully. I have these set of elements 10, 20, 30, 40, 50, 60. I have sorted the elements in an increasing order and placed in an array. Now, if I want to search for an element that is 50, I want to search for an element that is 50, that is called as data. Whether 50 is present in the list or not, yes, it is present in the list. But I do not know as to how I can employ this binary search algorithm to find out the middle element. In order to obtain the middle element, I will consider the three parameters as I said earlier, that is the left, right and mid. In order to obtain this, I will check whether this is the middle element. If this is the middle element, how many elements are there in the list now? This is called as 0th index, first, second, third, fourth, fifth. So totally 0 to 5 indicates it is 6 items are there. Now I will set one of the parameter, that is left, to the index 0, and another parameter called right towards n minus 1th location, that is this. How can I calculate the middle element? Obviously, it is a binary search algorithm. We can employ the formula called as mid is equal to left plus right by 2. That means 0 plus 5 is what? 0 plus 5 is 5 divided by 2, which is equal to 2.5. We will crop it and round off it to 2. Now this becomes the mid element. So if A of mid, and if I call this as an array A, what is the A of mid? A of mid is A of 2. That is A of 2 or A of mid is equal to 30. What is the data? 50 is to be searched. If the data item 50 is greater than 30 or less than 30, the item data 50 is greater than 30. If it is greater than 30, which case? Possible case, second case, data is greater than 30. A of mid, that is 50 is greater than 30. Then left is equal to mid plus 1. What is the meaning of that? I will shift the left from here to mid plus 1 position. Now this becomes my left in the next iteration. Suppose if the element to be searched is 20, that is, in this case, data is equal to 20. Initially, left was here, right was here. So, left plus right by 2 is what? That is 0 plus 5 by 2 is 2.5. If I round off that, I'll get the value 2. This becomes my mid. So, in this case, 20 is less than 30. Then right is equal to mid minus 1. This becomes the new right. This becomes my right. In case 1, in case 2, what if the element to be searched, that is 30, is equal to 30? We will return the item to be searched found, that is element found. This is the criteria. These are the 3 possible cases in which we apply the bisection formula. Moving forward into this, you will see that the binary search is used with sorted array or list. That is, it applies only for a sorted array. As I have already told you that a sorted array is one which requires the element to be searched is in the sorted or in the increasing order or in the decreasing order. Then only we can apply the binary search algorithm. Whereas in case of linear search, there was a possibility to apply the linear search algorithm even when the elements are not in the sorted order, or it can also be employed when it is in the unsorted order as well. So that is why we are taking the advantage of this binary search with the linear search. That is, the linear search is good enough to search the elements of an array even when they are not sorted. But that is not the case with binary search. The element must have been sorted first, then the elements can be searched and predicted in the list or an array. That is the first condition. In order to employ the binary search, the elements must always be sorted. Then we can apply the binary search algorithm. Then, which is the other criteria? We must also have 3 parameters. One is left and the other one is right, and then the middle. These 3 parameters must be chosen. And which is the other possible cases I can consider? If the data item to be searched is less than the middle element, then we shift the left parameter from the leftmost bit position to the middle plus 1. If the element to be searched, that is data, is less than A of mid, then we will shift the rightmost parameter from the rightmost bit position to the mid minus 1 position. If the element to be searched is greater than element present in the list, that is, the element to be searched is greater than the middle element, then we shift leftmost bit position to the mid plus 1 position. By doing these operations repetitively or recursively, we will find the element in the middle position. Then the element's position is returned to the user. That is, at which position the element is present in a list is going to be determined. If that is the case, we shall consider that if we get a match, we return the index of the middle element. In this case, I want to search for an item 23 in the list. Where is that 23? It is in the 5th position. Initially, in the first iteration, I will not get the value or the item 23 in the list when the first time middle operation is applied. That is, mid is equal to low plus I by 2 or left plus right by 2 is applied. I won't get the item which I wanted to search in the list. Later on, when I find that this condition 23 is greater than 16, that is greater than the middle element, we say that we shift the items from left to this position, that is from middle plus 1. Then, if you look at this binary search, if we do not match, we check whether the element to be searched is lesser or greater than in value than the middle element. The same condition is applied here. See here, initially I want to search for an item 23, which is present in the 5th position. Totally, how many elements are there in the list? We have 0 to 9. That is 0 to 9 is equal to 10 items. This is an even numbered array. Now, if I place left is equal to 0 and right is equal to 9, mid is equal to left plus right by 2. That is, mid is equal to 0 plus 9 by 2, which is equal to 4.5. If I round off this, I'll get the value 4. That is, mid is equal to 4. Where is that mid? M is equal to mid. I will get the mid value here at this position. Then in the second iteration, I will search for the item whether data, that is 23, is greater than 16, greater than A of mid. If data is greater than A of mid, what has to be done? If data is greater than A of mid, I will shift the left from here to mid plus 1 location. Left is equal to mid plus 1. Else, right is equal to mid minus 1. Now with this condition, with this criteria, I can find out the middle element. Now I have this criteria, that is data to be searched is greater than this. So this becomes mid plus 1. This condition is satisfied. That is 23 is greater than 16. This condition is satisfied when the control comes here, enters inside this, left equal to mid plus 1. Now this becomes left now. In this case, this becomes left now. Where is the right? Right is present in the same location, that is in this. What is the value of this? Left is equal to 5 now. 5 plus 9 is what? 14. 14 by 2. That is 7. You will get 7. M is equal to 7. This is my mid element now. Now 23 is greater than 56 or less than 56? It is less than 56. That means 56 is greater than 23. That means data 23, next time in the next iteration, 23 is checked here. What is the value of that data? That is 23. What is A of mid here? 56. 23 is greater than 56? No. It comes to the else part. Right is equal to mid minus 1. That means this becomes your next item. See, you can see to it here. This becomes right and this becomes your left. Then left plus right by 2 in the next iteration. 5 plus 6 by 2. 5 plus 6 is what? 11. 11 by 2 is 5.5, which is rounded off to 5. So this becomes your mid. In the next iteration, you have left is equal to 5, right is equal to 6, middle is equal to 5. Now again 23 is present in the fifth location. But what is the value of this R, right? That is A of 6. That is 6. 38. Now we have the middle element. If the element is found, what is to be returned? That is A of mid. If data is equal to A of mid. Return the position, the index of that position. What is the index of that? M, 5. What is that? Return mid. Not A of mid. If I say that A of mid, it would be 23. Yes, of course, we want to search for an item 23. But we want to return the position where exactly the value 23 is present in the list. So I am returning mid here. So these kind of iterative or recursive operations are performed on an array of sorted list. Now in this case, you shall see that the binary search working principle. That is, if the element or number to be searched is greater in value than the middle element, then we pick the leftmost parameter from the leftmost bit position to the mid plus 1 position. Then, if the element to be searched is less than the middle element, then we shift the rightmost bit parameter from the rightmost bit position to the mid minus 1 position. So then we move to the step 1. If the element or number to be searched is lesser in the value than the middle element, then we pick the elements from the left side to the mid plus 1 position and start from the step 1. So this process is repeated here. Binary search is useful when there are larger number of elements in an array and they are sorted. This is useful only when we have large number of elements. Suppose if you have an array of 1000 elements, array of 10,000 elements, then you can employ this binary search algorithm, because there is no need to search the elements sequentially from the one end of the array to the other end of the array, because it drops the calculation of searching an element by half in every iteration. So that increases the speed of execution. Then obviously the time complexity of a binary search algorithm is less than the linear search algorithm. This binary search algorithm applies only on a sorted array. The only limitation is that the elements must be sorted for the binary search algorithm to work on it. Here, how does the algorithm works? Let us see to it. Start with the middle element. If the target value is equal to the middle element, print that the element found. Else, move to that. If not, move to that. The target element value is greater than the middle element, then shift the value from right to of the middle index. If the target element, that is the middle element, is this, left element is this, right element is this. If the element to be searched is greater than the middle element, then we shift it from left to mid plus 1th position. Else we shift the middle element or the other parameter, that is the right parameter, from here to mid minus 1st position. The same thing is explained here. When a match is found, return the index of the element, that is mid. Return mid was explained here in the coding. Return mid. When the match data is equal to A of mid, return mid. If there is no match, that means if there is no element present in the list, that means whatever the item we want to search for is not present in the list at all, then we have to return -1. That means an unsuccessful search. There is no element present in the list. Then the worst case time complexity is also less than the linear search. That means the time taken to predict an unknown value which is not present in the list is also less than the linear search algorithm. There are three cases. One is best case efficiency, other one is worst case efficiency, third one is average case time complexity or efficiency, I can say that. In all these cases, whether it is the element is present in the first position, it is not a matter for binary search. The binary search criteria is to have the middle element. If the element is present in the middle element in the first case itself, then the item is obtained. If the element is not present in the middle element, then it has to search through either towards the left of the array or towards the right of the array. That is the concept of binary search. Now let us take one more example here with a few calculations. I want to search for an item 70. 70 is present in 6th index location. This is my index location. There are 10 items present in the list ranging from 0 to 9. Now I will set the left parameter as 0 and the right parameter as 9. So obviously my mid is equal to left plus right by 2. That is mid is equal to, for this case, 0 plus 9 by 2, which is 4.5. I will round off this to 4. That is mid is equal to 4 initially in the first iteration. That is, this becomes my 4. This becomes my mid element. You will see that in the next slide. Mid is equal to 4. I will check whether if A of data to be searched is greater than A of mid. What is the meaning of that? If 70 is greater than A of mid. A of mid means what? 50. Yes, it is 70 is greater than 50. Then what has to be done? I have to shift the leftmost parameter from here to here. This becomes my left in the next iteration. And the right remains same in the same position. Then I will shift the mid from here to left plus right by 2. What is the value of left now? In the second iteration or in the second recursive operation? 5 plus 9 is 14 by 2, that is 7. Obviously, mid is equal to 7. It shifts from here to here. This becomes my mid in the second recursive operation. Now, I will search whether data, that is 70, is greater than 80. No, it is not at all satisfied. So, it has to say that if it is less than that, I have to shift the right from here to this position. This becomes my new rightmost bit from here to here. Now, if you look at this, in the previous slide, you observed that this is your left and this right remains same. The same thing is explained here, and this becomes your mid. This becomes your mid. Now, if I apply that left plus right by 2, this becomes your right. Now, if I say that A of mid, again, left plus right by 2, that is 5 plus 6 by 2, which is 11 by 2, which is same as 5.5. I will round off this to 5. That is mid is equal to 5. Now, if that is the case, this becomes your new mid element. You will see in the next slide. This is your mid and this is your right. Now, see here. left and right both are pointing to the same location, that is to the 5th position. Now left and mid, right is pointing at this location. Please see to it. Right is pointing at this location 6, index number 6, and left is pointing at the index number 5. See here, at 6 and 5. Then if I apply the same formula, what happens? Mid is equal to low plus I by 2 or left plus right by 2. That is 5 plus 6 by 2 is equal to 11 by 2, which is 5. Now this becomes your middle element. Now both left and right are pointing, left and mid are pointing to the same location. With this, you say that 60, I want to search for an item 70, which is greater than mid. Again, what happens? Now, left has to be chosen and it has to be shifted from here to which position? Mid plus 1. This becomes your left. Now, left and right both are pointing to the index number 66. That is 70 is the item. Now, left 6 plus 6 by 2 is 12 by 2, that is equal to 6. Now, mid becomes equal to 6. This shifts from here to here. Then now A of mid, whether A of mid is what? 70. 70 is equal to 70. Yes, it is equal to 70. If that is the case, return the position of that middle element. What is that position? 6. Return the mid. Return mid, not A of mid. Return mid. That is the position. The element which you are searching for is present in the location 6. So this is my left and this is my mid. Now later mid becomes to the position of 6. It returns that. I hope you all are following the concepts which I am explaining in these sessions. Today I discussed about the binary search. If you have any questions, kindly let us know about the algorithms I am discussing. Thank you very much. Thank you all.